Hi guys, so this is a quick little lesson on what to do as we've combined our different naming systems together. So for those of you that are remote and asked for me to mail some resources home, this was included. I believe I copied it on yellow paper for you guys. For those of you that are in my in-person class, you're going to get a hard copy of this from me, so you don't have to worry about printing it out. I will provide you with a copy. This is kind of like a dichotomous key that biologists use for determining like what type of tree something is, and dichotomous keys have lots of different applications. So basically this is a tree to help you decide what to do when naming. So right now we have not covered anything off of the right hand side of this sheet. Everything is coming from this left hand side. So what that tells us is that all of our formulas, our names and compounds, all contain a metal. So they're all what's called ionic because it's a positive and anion first. And so the first question is we're going to be answering yes to all of these currently. And so the positive ion has to be first. And then the big thing here is what type of positive. So we have three options right now. There is one polyatomic cation, if you remember, and that's the very first one on your polyatomic list, and that's ammonium. And then from there, you decide what kind of negative ion do you have. The big thing that a lot of students struggle with is from yesterday's lesson is deciding, do I need a Roman numeral or not? That's the part that gets challenging as we combine our different systems together, determining what is the most appropriate thing to include in its name. And so I've got a few example problems just to help you decide what's appropriate. So I've got my periodic table and polyatomic list for that. So I just wrote up some quick examples, and I have kind of 8 total examples. Two are these 4 going to the formula, and then the other 4 are going in the reverse direction. So this first one is I have calcium bromide. And so when you take a look at it, the big thing that we're working with right now is, yes, everything is a positive and negative. So we need to know charges to determine subscripts. So again, the big thing that's going to distinguish where I get my information from right now is if there's Roman numerals present or not. So you can see in A and C that we have no Roman numerals. That's because they are in these families here with a fixed charge, the alkaline earth and aluminum category. And so this first one is calcium bromide. And so calcium, I can look at my periodic table. I know that it's got a fixed charge of a +2. So then the other thing that we've done now is determining if we have a polyatomic or not. If you can't find it on your polyatomic list, then that means it's an element off the periodic table. But again, there's other clues. Like here we have bromide that ends in "ide," so I know that I'm working with bromine with a -1 charge. So those are some of the decisions we're having to make is, are we working with a transition metal or not? And are we working with a polyatomic or not? So the crossing down part, I don't think is really giving you guys much of a challenge or much difficulty when it comes to that process. So CaBr2. So here we have iron 3 oxide. When I go to my periodic table, I see it's in the D block. That's where I don't have a certain charge because it's a transition metal. So if you remember, the Roman numeral tells us the charge. So it does a lot of the work for us. So I know my symbol is Fe plus 3. So the second half, the anion, I have to decide, is it monoatomic, meaning made out of one element like bromine was in the example above, or is it a polyatomic? So again, oxide is a good indicator, the "ide" ending, that it's an element off the periodic table, indicating oxygen with a -2 charge. I can see charges aren't canceling here and they cannot simplify, so my final formula is Fe2O3, and I'm done. So here we have strontium phosphite. So again, there's no Roman numerals. I know its charge. It's an alkaline earth metal. It is a +2. So here my suffix is "ite." That is how I have a good indicator now that I need to reference my polyatomic list and find phosphite. So here I can see phosphite. The formula is the PO3 with a -3 charge. So now I'm working with my rules in terms of writing a formula with a polyatomic. Crossing down, my subscript on the strontium is going to be a 3. It's monatomic, so no parentheses is needed. The PO3, however, is getting a new subscript of 2. Therefore, it goes in parentheses. and that subscript 3 outside. So last example, zinc 2 carbonate. Again, I have a Roman numeral here, so I know zinc is a +2 charge. Carbonate, so carbonate, that 8 ending, again, tells me to look polyatomic list. It's right here at the top of the -2 column with formula of CO3 minus 2. Now in this example, I can see that I have a +2 minus 2, therefore charges cancel, therefore no parentheses are required on the polyatomic component. So that's kind of the decisions you need to make. And these are kind of 4 broad examples that apply to the different scenarios we've seen so far. So this is the part that I feel is more challenging to students, is where you have a formula and you need to go to a name. Because I feel like you have less obvious indicators like a Roman numeral and a suffix to work with. And so here you have to decide, and this is where that naming tree is going to be really useful. So here we have that it's ionic, and I know it's ionic because I have a positive and negative. I have a metal and I have a nonmetal. So the positive ion is first. So we have to decide, so first of all, this is not ammonium. So I have to decide, is it a type 1 or type 2? So you have to decide, is it a transition metal or not? So transition metals, again, are the D block, and these metals down here in this lower region in the P block. Well, sodium is not included in there. So that makes this a type 1. So it tells you to use the name of the atom. So again, this is just telling us that no Roman numeral is needed. So Na is sodium. So then from there, what is the negative? Is it monoatomic or polyatomic? Well, it's just made out of one type, so it's monoatomic. So you add "ide" to your stem. So this is phosphorus, so this becomes phosphide. So again, because sodium is not a transition metal, a Roman numeral is not needed. Now, the next one we have SnCl2. So we see that Sn, again, it's not in the true transition metals, but it's kind of lumped in with the transition metals. These ones down here mimic kind of what the transition metals do. And so that tells us that, yes, we have a metal. The positive is first, so type 1 or type 2. It is a type 2 because it's a transition metal. So that means we have to name this tin. I'm going to go ahead and put a spot for my Roman numeral. And then what's the negative? Is it mono or poly? This is mono, so we just change it to "ide, so this is chloride. The part that students oftentimes forget is those steps that we covered in figuring out what is our subscript. Remember, that process is crossing back up, +2, -1. You check out your chlorine. Chlorine is in fact a -1. You're ready to name. So this is tin 2 chloride. The next example here is FeOH3. So the positive is first. Is it a type 1 or type 2? It's going to be a type 2 because iron is in the transition metal region. So this is, or not, I think I said tin, sorry, but I meant iron. So here's iron. We are going to need a Roman numeral. And is it mono or poly? Well, we can see 2 different elements, therefore it's a polyatomic. So we have our list that we can refer to. When you look up OH, that is hydroxide. Because our polyatomic is in parentheses, I'm bringing the 3 up to that, a 1 up to it. I check out my negative. When you refer to that polyatomic list, that is correct. Therefore, this is correct, and you're ready to name iron 3 hydroxide. Last example then, we have Al. So Al is not a transition metal, and it has a fixed charge. So therefore, this is a type 1. Does not need a Roman numeral charge. So this is Al. So that's aluminum. So then we just need to name our negative. It's a polyatomic because I see 2 different elements. So I refer to my list, and this is phosphate. So this was just a really quick summary on what naming system to use. If you have questions, need help, just let me know.